Okay, so this figure shows an input characteristics of a bipolar junction transistor when transistor is biased in a common emitter configuration. So what is common emitter configuration? We can see that. Let's say you have the NPN transistor. This is your N, this is your P region, and that's your N region again. And let's name the regions. Collector, this is your base, and this is the emitter. So that's your emitter. Let's write it. So common emitter configuration means your base emitter junction is forward biased. So let's apply a positive voltage to the P and negative voltage to the N. So that becomes your forward bias, and due to that the input current is called as base current IB. And the collector emitter junction is reverse bias. So we'll say that that's your positive to the N and negative to the N again. So that is your reverse bias. This voltage you call it as a VCE. That's your VCE. Let me correct it. That's your VCE. And this voltage you call it as a VBE. Okay, so here on the x-axis what you see is a VBE, and here on the y-axis is your input current IB. So that's your input current IB. So in this common emitter configuration, your input junction is forward bias and the output junction is reverse bias. So with this condition, we say that for every increment in the input voltage, that is VBE, until it reaches the 0.6 volt, the input current IB is essentially 0, and after that it rises to a high level. So for different voltages of the VCE, it shows how the input current IB is plotted. Now that is the characteristics for a common emitter configuration. Your task is to draw the characteristics and tell which current versus which voltage for the common base configuration. Can you name that? Similarly, draw the characteristics, input characteristics for a voltage and the current for the common collector configuration. So that's an exercise for you.